Hello, I'm Richard with EV4U Custom Conversions, and welcome to part 2 of Karmann Gets an Upgrade. In the last episode, we talked about replacing the net gain control. The Curtis controller with an Evnetics Soliton Jr. And we originally had ordered it, and should have been 2 days to get here. And then we got an email notification with a tracking number that said it would be 8 days. As it turned out, it took 11 days. But anyway, at long last, we have our Soliton Jr. But because it took so long, I was without my Karmann Ghia, which is my daily driver, and so I had to drive something else in the interim. But it's not too bad of a ride, and we made it through the 11 days. But let's go take a look at the Evnetics Jr. Well, here they are side by side. This is the Curtis 1231C, the long time standard for conversions. And next to it is the Soliton Jr. by Evnetics. And you can see it's a little bit wider. Lengthwise, they're pretty close. They're maybe within an inch. And then height-wise, the Soliton's a little bigger also. So in physical size, it's a little bit bigger controller. Weight-wise, I haven't put them on the scale. I think the shipping weight on this was like 22 pounds. They're very, very close in weight. I mean, just picking them up, I can't tell the difference. But we're going to concentrate on the Soliton Jr. The Curtis is out of here, and so let's move on and talk about how we're going to install this new Soliton Jr. controller in our Karmann Ghia. Well, first let's do a little overview of the Soliton Jr. controller. And it comes with your owner's manual. It's about 33 pages. And let's just talk about a few of the things that are different about this than the Curtis. It says that the main contactor and pre-charge controller is built in. We talked about that earlier. It says it's splash-proof, nickel-plated aluminum enclosure, and rugged design based on 600-volt industrial IGBT modules. High reliability 600-volt film capacitors in the power stage. 1.5 volt max voltage drop at maximum output current. This says 0.8 volts is typical. It has an idle feature. State-of-the-art laminated bus structure extracts maximum performance from the IGBTs by reducing noise, ringing, and spikes. Full optical isolation between the traction battery and the 12-volt system. Fully configurable with an ordinary web browser. Performance data continuously streamed to the Ethernet port. Throttle directly controls motor current torque for a natural driving feel. Motor current ramp rate can be adjusted. It can on the Curtis also. Randomized pulse skipping maintains precise control of motor current all the way down to 0 amps for smooth starts and easy low-speed driving without emitting an annoying whine, which is sometimes a complaint people have with the Curtis. All low voltage connections are protected against reverse polarity spikes and treat 5 volts as maximum but tolerate up to 15 volts for convenience. You've got a tachometer input. The brake input overrides the throttle. Reverse input reduces maximum throttle for motor voltage when active. You got 3 programmable inputs and an error light, which you can connect to your check engine light. We're going to connect it to the same light that our motor temperature goes to, so both functions will turn on the same light in the dash of the Karmann Ghia. So anyway, those are kind of the highlights. We've got 2 thermostatically controlled fans on the top right here. This is the battery side, and this is the motor side. This is the input and output for our internal liquid cooling, which we will be using. That'll give us 500 amps continuous out of this. And so what we need to do is we need to 2 main things. The mechanical, physical part of mounting and putting this in the vehicle. And the second is modifying our wiring that we had that was specific to the Curtis controller to now work with this new controller, which has some, there's differences between the two. One, we don't have the main contactor. We don't have to have what we called our pot box relay, which switched on the controller. It had a KSI input on it. That's all done internally. We don't have to do that. So a little bit different wiring externally that we're going to have to modify. And we'll talk about that in more detail. But first, let's see how this is going to mount on our component board, our heatsink from before. Well, here's our component board heatsink. Like I said, it's a 12 by 24 1/4-inch thick aluminum, which we use with the Curtises for the heatsink and for dissipating heat. That's how they work. They're an air-cooled controller. And so some of the holes we're going to be reusing, the holes on the side here that were used for our little side pieces, of which will go back in place. The other side has the coolant reservoir. This side has our terminal strip and some electronics. And we have our mounting holes where this mounts to the firewall in the Karmann Ghia, and a few other holes that will be reused. So first off, we had to decide where this would fit. And so to miss our mounting holes and to miss the hinge on the deck lid, this is where we've come up with. Now, we still need to make sure we've got clearance depth-wise and so forth. We need to double check that. So these are our mounting holes on the bottom here. We're going to clear those. There's one on the side here. That's what limits our position to the left. We want to leave room to put the wrench on there and tighten these things up. So that's the position of the controller then. Tight fit, but it's going to work without modifying our mounting in the vehicle. This is where our throttle cable comes in, and before it came up, it went over here to our Curtis pot box, which was mounted over like this, and there was another pulley here, and it came over like such. This is the OEM style throttle that we're using. This is just a throttle position indicator like you have on most your, I know the GM vehicles use this similar part to this, and basically deals with a 5-volt signal. And so we took a straight edge and we determined where our pulley center was, and then using a square came up here so that we could get the throw of this throttle in line with it. And this is exactly how that's going to go now. We will have to determine which hole by measuring the amount of throw that we have and need to provide. So that's where the throttle is going to go. Because our cabling was designed to go to our contactor on the positive side, which was right here. I'm hoping we have enough length to make it right here to go to our controller. And then the negative side and our charging came off of our shunt. So we will just have to make a short run from the shunt to the negative side of the controller. So all that's very simple and doable. Shouldn't be any problems. We are going to have to come up with a little different wiring scenario for our side panel here that accommodated the idiosyncrasies of the Curtis controller. This has to do with the this is the energy management module for the Elite Power Solutions set up with our GBS cells in that vehicle. This was a throttle position safety relay so that if you had partial throttle and you turned on the key, it wouldn't go anywhere. And so not going to need that on this one, it's built in. But we're still going to need to incorporate some of the other safeties that we had in the vehicle that were in series with this. And so we will make some wiring modifications. And then the other issue is we want to be able to connect our coolant lines, which previously connected to our chill plate, which still has the heatsink grease on it. But this was the chill plate that used to go on the back side of the heatsink here. And so that's where our lines were designed for originally, to be on the back side here. So we're going to have to reroute them. And I think we're going to have to change one of them, maybe not. I have to check into it a little closer, but it looks like we may be able to get by without changing any of our hose lines for our coolant, which would be nice. The less we have to do to modify things, the better. But one of our lines we're going to have, the input line, we're going to go with a 90 off to the side like this because it's going to be coming kind of from this back side like this, and we can come in. The other one comes from below actually, and so we'll go straight in with the outlet port there. So that ought to work pretty nice. You can't put two elbows in here because these ports are too close to one another. You couldn't thread it in. But we can do one. We'll put the elbow in first, and then we'll put in the straight, and shouldn't be a problem. So that's kind of it in a nutshell as far as what we're going to do. So what we're going to do next is we've marked the new holes, and we've marked the existing holes. And so we will take this and actually take another piece and since we do a lot of these, I just happen to have another one laying around. We'll take another piece of aluminum and we will transfer all the holes to it. And once we do that, we can mount our components in place and make sure it fits in the vehicle. One of the things I'm going to do before all that is do a little check on the depth to make sure that we're going to clear the deck lid and so forth with the thickness that we have coming away from the firewall. Being that this is blockier, it's thicker than the Curtis was, and it's blockier, we need to make sure we're going to have the appropriate clearances. One thing that still obvious on this one, and we've seen it in the past on other Evnetics controllers that we've used, I don't know if they're just cranking them out that fast or what, but the edge here has a lot of sharp edges. We've got burrs. Just the attention to detail, just get the camera here, just isn't what I'd like to see. We'll go with a file and clean this up because it's sharp enough to cut your finger. Here's one, it's kind of an out-of-way spot, but very sharp burr all along here. And so it just, you know, not the, I mean, this is a top, you know, top-notch piece of equipment. Probably, you know, the best DC controller on the market today. I mean, I'm not aware of any that can give this a run for the money. There's the, oh geez, blank, the Zilla, which, you know, the Zilla was around, you know, long before Evnetics, and in the racing world is the standard. But this controller, really, in my mind, it's you don't have the hairball and all that to wire up. This is a much cleaner, simpler design. Works extremely well, and I think will one day become the new standard, both for on-road vehicles and for racing. But I would like to see a little more attention to detail. Like I said, I think it's possibly that they are kind of to the limits of their production abilities. So anyway, let's get this new board cut and drilled and ready to roll. Well, we've drilled the holes in our new plate. We sandwiched the two together and we drilled the holes that we had marked. We made a mark for our notches. We still have to cut those out. But it's really that easy once we already have a template. Makes it nice and easy. So we'll cut the notches and mount our components. Well, here's our new component board with components in place. We have the components that we previously had with some slight rewiring. We have our shunt. This will go to our most negative point in our pack. This will go to our controller, as well as our battery charger attaches here. And this will be our most positive point on our battery pack, coming from our emergency and service disconnect. And this line right here goes over here, and that is again the EMS system from Elite Power Solutions that was installed in the Karmann Ghia at the time of conversion. So it needs pack voltage as well as unswitched 12 volts in order to operate. This is where it gets its reading for the pack voltage. And it also has a connection here which is stayed with the vehicle, which goes to the individual sense boards on top of each of the cells that measure voltage and temperature of the individual cells. This again is all the connections that go to the vehicle. This goes to the temperature switch on the Impulse 9. This is our Evnetics throttle right here. And let me give you a shot at the bottom of the controller so that we can see our connections here. And of course the two connections on the right here go to our motor, positive and negative. The only connections we're currently making on the controller are the throttle connections right here, our ignition, 12 volt ground, and error light. And again, that will light the same light in the dash as the motor over temperature. Never had a motor go into over temperature, but if the light comes on, we're going to be investigating things, so we'll use the same light for both purposes. So next we will install it in the vehicle. But being as I started this after hours, it is now about the time my wife's going to start wondering where I am. So we'll install this in the vehicle tomorrow. What's left, of course, is the coolant connections, and so I got to go pick up the fittings for that. I don't think I have that size in stock, smaller than what we normally use, so we'll get that and get her installed. Well, here's a look at the Evnetics Soliton Jr. installed in the Karmann Ghia. We still have a few things to connect. Most notable, the blower. But we're going to, and I just have this finger tight on here right now, but we're going to remove the band, inspect the brushes, and blow out the motor while we've got it this far down. It was time to do that again. So this is our most positive coming into the controller. The small wire coming off here is the pack voltage that's going to the EMS module. This is our most negative. So everything is going through the shunt, including our charger, so we're watching current flow in both directions. We didn't have to make new cables for the pack positive and negative. They were fine lengthwise. We had to make a little one to go from the controller negative to the shunt. And then what we had used before going to the motor, they were both too short, so we had to make 2 new cables for that also. The coolant reservoir is being filled. We're going to have to, we'll turn that on and we can switch on the reservoir and, or not the reservoir, but the pump and the fans separately right here, as well as we can disable them separately. But we'll pump it through the system. The pump has got fluid to it, and we've got coolant in the reservoir. So we'll purge all the air and get coolant throughout the system. So this is the coming from the pump through the cooler. This is the inlet on the left here. Goes through the controller. Did I say cooler? Anyway, it's coming from the pump to the controller, goes through the controller, out of the controller, through the radiator, back to our reservoir, out of the reservoir to the pump. So anyway, and that's going to run, you can set them up to where the Evnetics has it set up to where you can have it come on when the fans come on. We're going to run it all the time. So the thing's always going to be cool and it'll always have a head start. It's just hot here most of the year, so no use playing around. One less relay and one less thing to go wrong. We turn on the ignition, the pump comes on and the fans come on the radiator. This is the throttle with a secondary return spring. We always like to run 2 return springs just in case. And so that's where we are right now. So like I said, inspect the brushes, blow out the motor, install the blower, kind of clean things up. Our wire and stuff is all dirty from messing around with the aluminum, which gets your hands black, and then handling the wire and everything. Kind of get tired of washing your hands. So anyway, we'll clean everything up, make it look nice. And then we still also have to program the controller through the Ethernet port right here on the bottom. We showed you our low voltage hookups while it was still over at the workbench. But you can see it makes for a nice, clean installation. Very simple and hopefully very dependable. We haven't had any problems with Evnetics in the past. We'd never had a problem with the Curtis before either, but the rear engine vehicles like this where we have you know, things mounted in the back, the Karmann Ghia gets no airflow back here. And so we have to keep the motor and controller cool by other means. We don't have natural airflow like you do with a front engine vehicle. We can run the Curtis's 45 miles down the freeway, get back, and they're, you know, you can touch and leave your hand on it. They're just fine. Running in the back of a Karmann Ghia, you can't touch the thing, it gets so hot. And like I said, a run like that, the last mile, it will sometimes go into thermal cutback. So the Curtis, you know, did what we asked of it. It was just working too hard. This should allow us to have some overkill and margin as far as the demands on the controller and its ability to cool itself. So let's finish it up. Well, the brushes look good. The commutator looks good. The brushes are wearing evenly. It smells good. And everything visually looks as it should. Also took this opportunity to inspect a few things on the underside of the vehicle. You can see the radiator back down there. Just the bottom edge of it. And so this is looking good. Like I said, we'll button her up now after we blow out the motor. Running the blower on here really keeps the carbon dust down and doesn't let it build up. But we like to inspect the brushes and blow things out every 3,000 or 4,000 miles just to keep tabs on things. So we'll go ahead and do that right now. Well, we've got everything installed. We ran the cooling system, made sure everything's working, got the air out of the system, tested everything, and then we connected to the Ethernet port on the controller and onto our laptop and set all the parameters that we wanted to set on the controller. And for this application, we're not doing anything fancy. We're not controlling anything with the controller. And so we basically, we're not running a tack on this one. And so we just set our throttle. We calibrated the throttle. We inputted our minimum battery voltage at no current, our minimum battery voltage at full current, maximum battery current, maximum motor voltage, maximum motor current, and maximum motor power, and the slew rate. And so just a matter of a couple minutes to do all this, and you're ready to roll. So that's what we're going to do next. We're going to roll. We'll install the GoPro and take you along for our little road test, make sure everything's working as it should. So let's go for a ride. One last look before we close the deck lid. There's the new Evnetics Soliton Jr controller, cooling reservoir, throttle, shunt, EMS system, terminal strip, Impulse 9 motor with blower. Very, very simple. Let's go see how it works.